Welcome. We're going to get into a newer topic for discussion, and that would be functional group nomenclature. Now, previously we did learn how to how to name compounds that contain a single bond, double, or triple bond. But then we shifted gears slightly to just construct structures involving oxygens, halogens, and nitrogens. Now that's very, very important that we learned that first before we actually named functional groups, because learning how to actually draw structures with oxygen, nitrogen, and halogen is such an important skill that just opens up the door for so many different things to be learned. With that said, this might appear a little daunting for some of you. These are different functional groups we have. Now, when a compound contains a functional group, it takes priority as far as numbering goes. Okay? So when you have a compound that just not only contains carbon and hydrogen, but when it contains oxygen or nitrogen or halogens attached to it, then wherever that functional group is, it gets priority. Now, if you see that we haven't learned any new elements, then everything I just said, carbon, hydrogen, oxygen, nitrogens, and halogens, those are all the ones you on the screen. But when they're all in certain combination, it leads to a certain functional group. Okay, it can be an acid, it can be an aldehyde, it can be a ketone, alcohol, amines, halogens, nitro. Okay, some of which you may be already familiar with, like acids and alcohols. You may not be familiar with aldehydes and ketones. I don't want to lecture you about what all these individual things mean. Instead, I would rather show them just in action. So, and then we also have the ones that you already know, but then there's also a few on the list that I just added that you have not heard before. That's the isopropyl, isobutyl, secondary butyl, and tertiary butyl. I'm going to keep those four for later. Okay, because I want you to first understand these guys before I want you to understand those. Without further delay, let's get into naming aldehydes and ketones. Now, if you remember, I gave you a formula and I told you oxygen can exist as one double bond or two single bonds. Okay, and I had you actually construct. So if you had actually put it into the alkane formula, you would have got C6H14, and then you were wondering how I got that? Well, I got it from this formula, remember? And we said it has one double bond. For practical purposes and actually explaining these two concepts, let's assume that the one double bond is not in the chain, but it's actually only with the oxygen. In other words, I'm saying, let's not focus on the oxygen being two single bonds, but rather only focus on the case where the oxygen is a double bond. Okay, so 6 carbon, so 1, 2, 3, 4, 5, and 6, right? Now, if a compound contains a double bond O, and if it has to be an aldehyde, then it is at the end of the chain. It has to be at the end. Now, keep in mind, this is a carbon. This carbon is attached to a double bond O on one side, and this is another bond. So the fourth carbon, the fourth bond must be a hydrogen. That's what this is actually referring to. When you have an aldehyde, you have this functional group present, that is this one right here. Okay? And then, but then it could also, we said one double bond, so it can also appear as 3, 4, 5, and 6. If the double bond O appears at the end, aldehydes, the double bond O has to be at the end. Okay, for ketones, the double bond O has to be in the middle, anywhere in the chain. It just cannot be on the end. So that's how these two things are different. This is an aldehyde because the double bond O, when it is at the end, it typically will have a hydrogen. Okay, now it can be a OH, which makes it into an acid, but let's not get into that. But then if the double bond O is in the middle of the chain, then it becomes a ketone. That's a functional group. That's what this means is the carbon double bond O is sandwiched between two bonds, whereas the C double bond OH itself is an aldehyde. So we will actually do some exercises in class where first I would want you to just circle the functional groups. Now let's actually name these compounds. Okay, I'm going to draw maybe one more isomer where, 1, 2, 3, 4, 5. And then I'm going to just say the double bond OH is on the end, and then stick one group this way, and then maybe have the same one, but this time, okay, have the double bond O on this side, and then this. That's another isomer. Okay, so how do we name an aldehyde or a ketone? Once you've identified the aldehyde, then first you have to figure out the longest chain, which is 1, 2, 3, 4, 5, 6. You should start numbering from the side that's closer to one end where the functional group is present. In other words, you start numbering from the side 1, 2, 3, 4, 5, 6. The functional group gets preference for numbering. In other words, now we have hexane, right? Hexane is the longest chain. So to name this aldehyde, all you do is get rid of the E and write Al for aldehyde, and then locate the position, which is 1, where the functional group is located. Naming aldehydes and ketones are extremely simple. Similarly, this is ketone. You start numbering from the side that's closer to the end to which the functional group is attached. So 1, 2, 3, 4, 5, and 6. So it's a hexane again. So to name the ketone, you get rid of the E and replace it with a ONE, so hexanone. Where is it located? In the second position, so it's 2-hexanone. Aldehydes always will be 1 by default, and ketones could be 2, 3, 4, 5 depending on, but it cannot ever be 1. Aldehydes will always be 1, ketones will never be 1. Okay, so you have to still figure out the longest chain, so don't forget that. So let's go to this one. This is again an aldehyde because it's at the end, right? So you start numbering from here, 1, 2, 3, 4, 5. That's a pentane. So first you got to fix the last name, which is E, replace it with Al, so it's pentanal, right? 1-pentanal, because that's where the group is located. And then the methyl group is located in the 4th place, so 4-methyl 1-pentanal. The functional group itself is the last name. The substituent itself is the first name. So let's do it for this one again. Again, you start numbering from the side that's closer to the side containing the functional group. So 1, 2, 3, 4, 5. We know this is pentane, but it's a ketone because the double bond O is in the center. So it's, again, replace the E by ONE because it's a ketone and it's in the second position, so 2-pentanone, and the methyl group is in the 4th position, so 4-methyl 2-pentanone. Now, if you remember, this particular sequence of videos will only have one functional group, okay? Either aldehyde or ketone or alcohol or acid. For exam 2, we will actually have 2 functional groups, which that case we have to worry about priority. But first you have to learn to name one functional group. That's the foundational place. If you don't know how to name that, then you basically already lost the battle trying to name 2 functional groups. All right? So this is all I want to say on how to name aldehydes and ketones. I'm going to wrap this video up and then I'll come back with another functional group discussion. All right? So stay tuned.